Hello my dear friends, you're welcome to Joe Newton online class. Now here we are dealing with physics and we are looking at a problem from resistance of resistors. We are given resistors in a connections like this, and for the connection we have both series and parallel connection. So we are now asked to find the net or the equivalent or the combined or the total resistance in this circuit. Okay, very simple. In solving this, the first thing we do here is to look at the ones in parallel and we resolve it to be in series. Then we can now add up. So first, let us look at the resistance in parallel. We have two resistors in parallel here, 4 ohm and 4 ohm. So we find 1 over R total is equal to 1 over R1 plus 1 over R2, since there are two. And these are the 4 ohm and 4 ohm, which will give us 1 over 4 plus 1 over 4. And of course, we know that 1 over 4 plus 1 over 4 will give us half. That is 1 over 2, which is half. Therefore, we have that 1 over R total is equal to 1 over 2. This is simple. Know that elementarily, 4 divided 4 here is what? 1 times 1. 1 plus 1 here will give us 2 over 4, which is equal to 1 over 2. This is a primary simplification. So from here, our R total is equal to the inverse of this, which is what? 2 ohm. That is in parallel. In parallel. Remember, you start with 1 over R total, not R total is equal to. Don't make that mistake. Then for series, we now go for resistors in series. Resistance in series. In series. Then in series connection here, these are parallel connection. Then these are series connection. Then in series connection, the same way, how to find the combined or the total resistance is just by algebraic addition, that is arithmetic addition, summation of the resistors in series. But in parallel, the reciprocal of the total is equal to the sum of the reciprocal of the individual resistors in parallel. And that is what we have just done successfully and obtained 2 ohms. By implication, when resistors are in parallel, the equivalent resistance is going to be minimum, to diminish to minimum. Which means for you to get maximum resistances, you ought to connect in what? In series. Unlike what is obtainable in capacitance, which is the reciprocal of this case, or the opposite of this case. Of course, we know that a resistor is a device, an electrical component that opposes the flow of what? Current in a circuit. Now let us continue our task. Here in series, we have R total is equal to 3 ohm plus 2 ohm. That is it. That is R1 plus R2. Now look at this now. 3 ohm plus 2 ohm. Then we have already obtained another 2 ohms here. You see. And this one now has been unified to be in series connection with other ones. So we add it up too. Then plus this one. Plus this 2 ohm as well. That is it. So our R total in series now, you have this plus this, then the total resistance will be now, we add to this as well. So that is it. So finally, we now have 3 plus 2 is 5, plus another 2 is what? 7 ohm. So the total resistance in this circuit is what? Total resistance is what? 7 ohms. Remember what we did? We found these ones in parallel and we got 2 ohms. Then add it up to this now to make the total in series, because we have unified this to be in series value with the other ones. So we have this plus what we obtain here. We have 7 ohms. Thank you so much. Of course, R in total in series is addition. So for more of these calculations in physics or solutions in physics and mathematics, you visit my YouTube channel at Joe Newton Online Class. Subscribe for more notifications. It is free. Then share and like. The same thing applies to my Facebook page at Joe Newton Online Class. Thank you.